Space weather is the field that studies how what's going on the sun affects us here on the Earth in our near space environment and on the space environment on other planets.
For a large eruption, the sun produces a flash of light, which we call the solar flare. It also produces a huge ball of material traveling away from the sun we call coronal mass ejection. And both of those phenomena can accelerate subatomic particles, which we call solar energetic particles. These three things together make up a solar storm.
A coronal mass ejection, or CME, is an eruption of plasma from the sun that shoots out into space, and it could affect us here at Earth. A solar flare is a huge release of energy that converts the magnetic energy of the sun into heat, into light. It accelerates particles and can really heat up the plasma in order of minutes to over 60 million Kelvin. Solar energetic particles are particles of plasma that are accelerated at the flare site from the energy that's released in the flare. And these particles can be accelerated up to almost 80% of the speed of light.
And a coronal mass ejection, when it's traveling so fast, creates a shock, and that can create solar energetic particles.
Solar flares and CMEs are all driven by magnetic reconnection. This is where the sun turns up the magnetic field, and then it causes oppositely directed magnetic fields to then annihilate. But you can't just get rid of magnetic field. You can't just get rid of energy. You have to convert that energy and transfer that energy into other things, such as plasma motions, accelerating the plasma, heating up the plasma, and also giving out more light.
But a CME is that material and that magnetic field line just getting thrown away from the sun due to this interaction, whereas a flare is the sort of close to the surface phenomena where the twisting and the snapping occurs, and therefore you get all this heat and kinetic energy.
Solar flares and coronal mass ejections do not always hit Earth. They happen all over the sun, and depending on where on the sun they occur, determines whether or not they're going to travel towards the Earth.
Some of them could be shot off to the side and just miss us completely. They could go up, they could go left. Some are like curveballs that a pitcher will throw. They could seemingly come straight for us and then miss us completely.
Space weather can have several different effects on the Earth and the near-Earth environment. In space, it can create dangerous radiation in the form of particles, which is detrimental to the health of astronauts. These particles, as well as solar flares, can cause damage to satellites in near-Earth orbit. In addition, electromagnetic disturbances created by geomagnetic storms can affect power transmission on the ground, can also disrupt communication, but space weather has no direct effect on human beings themselves.
We are protected here on the surface of the Earth from solar flares and coronal mass ejections when they impact the Earth due to the magnetic field of the Earth called the magnetosphere, which deflects the magnetic field and the energetic particles, as well as the atmosphere, which absorbs the higher levels of radiation.
Most of the energy that's associated with a solar flare or a coronal mass ejection doesn't even reach the surface of the Earth. So even the biggest of flares isn't going to affect you here at Earth.
When a large solar eruption occurs, there are generally three things that happen. Each of these takes a different amount of time to reach the Earth. The solar flare, because it's light, travels at the speed of light and takes approximately 8 minutes to reach us. The solar energetic particles are traveling extremely fast, close to the speed of light, but not exactly the speed of light. So they take roughly 20 to 30 minutes to reach us. The coronal mass ejection is much slower, and that takes about 1 to 4 days to reach us.
The sun goes through what we call a solar activity cycle, where every 11 years on average, it will go from a very low period of solar activity, meaning sunspots and solar storms, to another period of low activity, and in between it goes through what we call solar maximum. At solar maximum, the sun has a very complicated magnetic field structure, and therefore it creates a lot more sunspots and a lot more solar storms like flares and CMEs. It's very important to be able to forecast solar events because they can affect our technology, our satellites, they can cause power grids to be affected. So as we become more and more technologically advanced, it becomes more important to be able to forecast such events.